Alrighty, we are live. Thanks everybody for tuning in. This is going to be a wonderful stream for more novice level developers. However, I'm hoping we can have some hidden gems in here for those with more moderate level of experience. Um, Introduce the people we got in here. My name is Sabian. I'm one of the community managers of OneLeaf. This stream is sponsored by OneLeaf. We're a nonprofit. The um, Discord link is in the description if you want to hop in and say hi and meet everybody. We're a community just about learning and working on open source projects together. We're starting a bunch of tutorial series trying to teach people as much as we can. Zach, you want to introduce yourself?
Yeah, I'm another community manager at OneLeaf. I mainly focus on the Swift projects. Don't know what to say after a great intro right there.
So yeah, we'll go ahead and dive right into it. Actually, one side note before we get too far into it, we do have the stream chat up, and we have Discord channels as well. If you guys are watching this from our Discord, feel free to post any questions in either of the chat channels that we have, and we'll get to it as soon as we're done with the current topic that we're talking about. We want this to be kind of a free flowing discussion. We have some things that we want to talk about and are going to talk about no matter what. But once it gets towards the end, we can kind of branch off to whatever people are interested in. So, what are we talking about today? We are talking about. Let's go ahead and start off with the data structure since we got our nice little whiteboard up here. So,
Okay.
what is a data structure, right? A data structure is the term's going to sound redundant, but it's a structure that allows you to hold data, right? I'm just saying it in a different way. In what data would you hold, right? Let's say you're building I don't know, some accounting framework, right? What data would that need to hold? Well, you need to have some data type to hold whatever resembles an employee. And an employee could have a salary, how long they've worked there, their name, personal information, stuff like that. Um, Other data structures could just be as simple as something to hold a number representing, the speed of an object. Data structures are really, they can get really complex, but at their core level, they're actually much more simple than people are led to believe. And they're also one of the core fundamentals that any good developer should know about, because the data structures that you decide to use in your programs make the most difference in the not only the speed but the efficiency of your program. So we wanted to break it down and go down to like the lowest level that we can and kind of um, catch people up on how these things work, because we have a lot of other videos on our YouTube channel. We've had a lot of requests for going down to the basics. I guess I didn't hit on it. We're going to talk about Git later on. So if you're not into the data structures, mute us and come back for that Git talk. Okay, so what are some common data structures that you would use, right? We're going to start out with the most basics, and those will be called the primitives. And the most common primitives that you'll see, and these are language agnostic, right? Language agnostic meaning it doesn't matter what language you're in, these things will be useful. And they'll kind of translate between languages. They instead of them having one name, they may have a slightly different name, but they'll still resemble they'll still hold the same data. So those types would be an integer, a float, a double, a string, a char, and a boolean. Okay, so I'm going to start with integer, float, and double because they're numeric types, right? They represent a number. So let's just go ahead and break it down to the very core of what they are. So in mathematics, for those of you that have taken mathematics class, an integer should be a concept that you're intimately familiar with. It's a whole number, right? It can be negative 1 billion, it can be 2, it can be 0, it can be any whole number, right? However, um, the computer has to have some way of storing that. So depending on the language that you're using, it may hold, you know, a finite number or a finite amount of digits, right? So, for example, in most languages or in most runtimes, integers are usually between like negative 2 million and positive 2 million because it holds 32 bits of data, right? So we're gonna give you some visuals here to help this maybe sink in a little bit deeper. And feel free to interrupt me if I'm going too fast here, Zach. So let's pretend that this box is the memory on your computer, right? And by memory I mean your RAM, right? The memory that your computer can dynamically allocate at any point in time. And so whenever you declare any one of these types, the integer, float, double, string, char, boolean, what your program is going to do is in your RAM it's going to say, okay, you need to allocate or set aside this memory that will fill up however much the size of this data type or data structure is. So an integer in most languages would be 32 bits, right? So that would be like 32, a sequence of 32 zeros and ones that makes up a number, right? And we're not going to go into binary here. If that's something that you guys have an interest in, we can make a secondary video on that. And we can go, way more in depth. You can also just Google how to do binary in programming, and that might help make some more sense. So, anyways, so an integer is just a whole number. A float is a floating point number. Floating point meaning the decimal. It's a decimal number, right? It's no longer a whole number. It's some sort of decimal number, right? So it could be 10.1, 100,000 dot 12345, whatever decimal you want, right? And a float is also 32 bits, but usually the way that they're structured, right, is somewhere in those 32 bits is um a how do I want to say this? A pointer to say where the decimal is, right? So if we just have a bunch of zeros and ones, somewhere in those zeros and ones needs to be the decimal, right? So a chunk of that 32 bits would be dedicated to telling you where the decimal is. One of those bits would be to tell you whether or not it's positive or negative, and then the rest would be the actual numbers representative of the float itself, right? And then a sorry, I can slow down. I talk really fast. Thank you for the reminder. I appreciate that. A double is the same thing as a float. However, it stores with twice the amount of memory, right? It's double the size of a float. So rather than using 32 bits, it's using 64 bits. So that means that you can either go to a higher number. So instead of with a float being able to go to 2 million, you can go to 2 to the 64th power of numbers, which would be a lot. I don't know it off the top of my head.
Yeah, that's a lot. That's
uh, every 10, every 2 to the 10 power adds 3 zeros, so it would be like 2 trillion ish. I could be completely off. And then I put these in the wrong order. We have char and string. I don't know if it's char, char. How do you pronounce it, Zach? How do you pronounce it?
uh char, I think.
Char for Charizard. Got it.
Well, I also play Guild Wars too, so it's also a race. So
Oh
yeah,
yeah.
a char. I don't know.
So a char is a character, right? And so if you go look up something like UTF-8, this is an encoding which basically says um, we're mapped to a certain amount of bits. So in this case, it would be 4 bytes or 32 bits. And basically it says if the bit value is 25, it represents a percent symbol. If the bit value is a 35, it represents a 5. 36 represents a 6, and so on, right? You get the point here. So basically it encodes a binary value into some character, right? And so the encoding that an iPhone uses and the encoding that a browser uses could be different. But the core concept is still there, right? Some sort of value is stored, and that is represented by some character, right? And a string, as the name implies, is a string of characters, right? So in most languages, we'll get to this later, but it's an array of characters, which literally just means like if I type out ASDF, A would be a char, S would be a char, D would be a char, and F would be a char. But the whole thing considered as one would be a string. And usually you'll see a string in most languages wrapped in quotes to represent that it's a string. And in most languages, you'll see a char wrapped in single quotes to represent that it's a character. The last data type is used for storing a true or a false, a boolean. You either are or you are not. Usually in most languages, it's represented by true or false. Um, I can't think of a language that wouldn't. So yeah, these are the primitive data
Oh, I
types.
can.
What's that?
Oh,
You can?
Objective C has yes and no.
Oh, does it? That's funny.
Yeah. Oh, it's horrible because they also have true and false.
Elon Tusk asks, "What's the difference between ASCII and Unicode?" They're just different formats, right? In ASCII, 0045 may represent A, whereas in Unicode, 0085 may represent A. So like maybe UTF-8 supports, maybe 1111 is an emoji, like a smile emoji, and maybe it's A in a different encoding. I don't know them off the top of my head. I'd have to look them up. Um, yeah, I hope that is a good description. Uh, Vineeth asks, is there a fixed size for string? And that's a really good question because in a lot of languages, you're allowed to just keep adding to a string, right? Like if I say I have ASDF at the end of it, I could just add letters to it, right? And so I feel like there's under the hood, it kind of depends on the language and how the system is running. I can think of two ways how this would work. One would be when you create the string, it says here's how much memory you can hold, similar to, we'll get to an array in a second, but it would work similar to an array. It would say, okay, we create this thing and it can hold 100 characters. And what happens when you add a 101th character? It says, hey, Mr. Operating System, this piece of memory that we allocated in the past, can we ask for another sequence of memory somewhere in my RAM to hold another chunk of characters? Right? And then somehow in the data structure of string, it would know to be able to point and say, the first 10 characters are here and the last 10 characters are here. And, it would just map it based on memory address and it would know that the end of this guy points to the beginning of this guy. And that's not something that you'd have to concern yourself with. A lot of this stuff is handled for you under the hood, right? Um, the only way I think you might run into a problem is if you have a string that's so long that it takes up more memory than your computer has RAM, and that might crash your program. The reason for that is your program would ask, hey, Mr. Operating System, Windows, Mac, Linux, do you have enough memory for me to allocate another chunk of memory? And Mr. Operating System would say, no, 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 you're not allowed to do that. You need to cancel your process because you're taking up too much memory. And I'm putting this in very simple layman's terms. Um, I'm trying to get the core concepts here, and if I'm taking it too simple, feel free to ask me to elaborate. The other way that I could think that the string would be allocated is it would say, instead of asking for a new chunk and kind of adding it to the end, it would say, okay, well, this chunk's full, and maybe the memory after it's being used. Well, let me just allocate a whole new thing and double its size, and now you have twice the amount of memory to work with. And then when you get full of that, it'll ask for another chunk, twice its size, and keep going, right? Or maybe it's not twice, maybe it's 1.5 times, something along those lines. Okay, we went over the very basic primitive types. What other questions do we got before I move on? I'll give you guys a couple seconds while I take a drink. Zach, feel free to add in here.
I'd like to just touch on the fact that in some languages, a string might not be a primitive. And that is more just based off of the high level part of the language. So some language might treat it as a primitive and act like it is. And some languages, it might not be a primitive. I
That's a
think Java is one of them where it's not, right?
that's
It's
a very
a
good distinction. I can give you an example in C sharp.
mhm,
It would treat integer, float, double, and boolean as primitive types, right? And the reason they would be primitive is because they can't be nullable. They can't be equal to nothing. A boolean is either true and a false, either true or false. Sorry. So when you make a boolean, even if you just say boolean x and then end the line with a semicolon, if you don't set it to anything, it'll have some sort of default value. Integer, float, and double, their default value may be 0 or it may be infinite or whatever the max value is. It doesn't matter what it is, but an integer has to have some value, right? That logically makes sense. Whereas a
yeah.
string could just be empty, right? There could just be nothing inside your string.
See, that's the weird part.
Um,
Is in Swift, we can have all of those types that you put, they can be optional. So and just elaborating on the fact that this switches language to language, but we're just trying to address the core concept of.
Yeah, and you guys are kind of in luck here, because Zach knows Swift really well, and I know C Sharp really well, and we both know Java pretty well. So we're going to come at this from different perspectives here, and hopefully be able to give you more insight as to how these things change depending on the language. Yep, Raid, you're
Yeah.
correct. In
Yep.
Swift, all these primitives are optional, meaning that they can be null. Yes.
Yep. It just depends on the language. Like Sabian said, C sharp treats it as they're primitives, like actual primitives, and it doesn't make sense that they can be null. But Swift, if you look at any of those primitives in air quotes, they're actually just structs. And you can look into the struct of that. But this is not on language
Um,
specifics. We'll just try to
yeah.
dip our toes in it.
And just in case you're unfamiliar with the terminology we're using here, null, nil, and undefined all mean the same thing. And this is kind of a hard concept to wrap your head around if you come from a math background. In math, you can't have the concept of nothing, right? A number has to be equal to something. Well, in programming, null or nil, two different ways of saying nil. Nil, I believe, comes from Latin, and undefined. The only example I can think of would be JavaScript calls it undefined instead of null or nil. Um, so what I'm going to propose a possible way this would work. In C sharp, for example, if we were to declare, let's say, a string, which is not a nullable type, it would say, "Hey, Mr. Operating System, declare this amount of memory for me and put something inside of it," right? It doesn't matter what it is. If it's null, it could just be, a bunch of zeros in the memory, right? Um, but the concept of null really means this spot in memory doesn't hold anything. It's not referencing anything, but we've told the operating system to say, "Hey, we want this amount of memory and RAM so that we can use it later and set it to something." Okay. Any other questions before I move on? We're gonna work our way into some more complex data types. I'll give you guys just a couple seconds while I take a drink. All right. Looks like we're good. So, what is the next most primitive data type I can think of? And I'm going to delete all of the inner things that we've stored here and keep our box to represent our RAM. And let's get rid of... I'll keep the extra boxes so that you guys can reference what we were talking about earlier. Okay, so the next most primitive types I can think of are arrays and lists. So what is an array? An array is a grouping of one data type. So in most languages, I have to generalize here because some languages may be different. You would say, if I declare an array, I want to say how many things are going to be in this array. So if we have an integer, for example, right? In memory, we want to say, I'm going to declare this block of memory as an integer array. And this array is literally just sections of memory. I'm trying to draw lines here, they're not supposed to be squares. So array would, for example, have 5 elements, right? And in here we could have, 1, 2, 3, 4, and 5. And basically when you declare an array, you would say, I want this many of elements. So in this case, I would have 5 elements, and you'd say the type of thing you want in that array, right? So that way, when the array is created, it knows how much memory to do, or how much memory to allocate, or request from the operating system. In this case, if we're using an integer array, it would say, I need as much space as would hold 5 integers. In this case, if an integer is 32 bits, we'd multiply that times 5 and get 160 bits, right? And they're just stored sequentially in memory, or however the program handles it. And the basic concepts of an array is it has instant access time because you know where these things are stored. They're all right next to each other and you have reference to the first spot in memory. The array's elements, or each individual section, are indexed, meaning you can access the first element by saying I want to get index 0. And let's change the numbers here so it's a little bit more clear. So let's say the first element of our array holds, that's supposed to be text, holds 12. The second element of our array holds 45, 1, 56, and I don't know, 555. Okay, so these are just chunks of memory that are holding these integer values. Thank you for putting that text there. So these are the indices, the indexes that represent the element that you want, right? So if I want to get the first element of the array, in most languages you would say array and then in brackets 0, and that would access the first element of the array. I know it may change depending on the language, but it is pretty common nowadays. Um, so arrays work for any data type, right? If I want to hold a float, each one of these boxes would just hold a float. If I want to hold a string, same thing. And if I want to hold a boolean, maybe a boolean would just hold, 1 bit, right? So the whole thing would just be 5 bits. Anything to add on arrays, Zach?
Um, just you might hear them, or arrays are very similar to some other things like lists, sequences, collections, and then I even put tuple, which is a little bit different, and I don't know if you want to
Yeah, we can
touch
touch
on
on
that
that.
specifically.
Okay.
Yeah, okay.
Any questions on arrays while we're on them? Arrays are used in most high-level languages: C Sharp, Java, Swift, Kotlin. I think Python either has just lists or just arrays. I don't remember. I think it's just lists.
Yeah.
Okay, so we're moving on to lists. So a list is very similar to an array, but it's a dynamic memory type, right? So when you create the list, it is just one empty box. And you say, I want to create a list of some type. I want to create a list of integers, right? And my list, when you create it, is going to be empty. And then you'd call, for example, list dot add, and then you'd put something in it. If you're using integers, you could add 1. If you're using a string, you could add, some string. Whatever type you want to put in, right? And then all that would do is it'd say, hey, Mr. Operating System, will you allocate enough memory for me to be able to add this to my list? And so now we'd have, when we call the add function, it would, add a box with, whatever we put in it. And then if we called add again, it would create another box and just keep requesting memory, right? In some languages, lists can be accessed similar to arrays by doing, you know, list at 0. In some languages, you have to do list dot, get, and then you have to pass in the index, and there's tons of ways to do it, but the concept is similar, right? You want to get something at an index, um, and there's multiple different extensions of a list. A linked list would be something that I could think about, where basically I don't hold reference to each of the individual items in my list. I only hold reference to the first guy, and the first guy holds reference to the second guy, and the second guy holds reference to the third guy, and so on. Um, so now we're kind of getting into talking about how data structures impact performance. And let's take, for example, the difference between an array and a list. When you create an array, let's say we want to create either a list with 100 elements or an array with 100 elements. When you create an array with 100 elements, the operating system says, boom, I'm going to create you this group of memory that's going to hold 100 things. Whereas in a list, you create your list and then you add one element and then you add one element until you get 100, right? Well, arrays may be more costly when you create it, but as you're adding to it, it's instant lookup because we know which index we want to put things in. If we know what index we want to put things in. Whereas a list, depending on the way it's handled, maybe when you first create the list, it just references, it just holds enough memory for one data type, and then when you add another one, it has to go request the operating system to give you another data slot, and so on and so on. So a list could be more expensive. It depends on the implementation. On average, they're more expensive than lists to um, add to. Whereas getting from lists and arrays, depending on their implementation, are about the same. It should be instant lookup, not instant, linear lookup time, right? Or constant lookup time. Sorry, my wording is getting off here. Um, and then we could talk about like how performance would impact sorting a list, searching through a list, and so on, right? So depending on the way your list is sorted, impacts how quick you can search through it, right? So if I want to find the number, it's not drawing. If I want to find the number 3 in my list, if it's if it's sorted, I could just cut the list in half, if it goes on to 4, 5, 6, and so on, right? I could just cut the list in half and say, is my number that I'm looking for less than that? Cool, then we can go on the other side and keep cutting it in half. And that would exponentially decrease the amount of times I have to look through it. The most naive way to search through a list would be to start at the first guy. Are you my number? No. Go to the next guy. Are you my number? No. And so on, right? So if your list is sorted, it allows you to come up with clever ways to search through it. So you can have, in some languages, they have uh, data types that are pre-sorted. So you can have a sorted list, for example. And when you add an element to a sorted list, When you insert it, it may take longer because it has to figure out where to put it, right? So for example, if we had 1, 2, 3, um, and we tried to put in 4, it would have to say, are we greater than 1? Yeah. Are we greater than 2? Yeah. Are we greater than 3? Yeah. Then it could insert 4, right? So it may take a while to figure out where to put it. But when you want to go search through it after it's been sorted, now it's way quicker, right? Um, I feel like I'm trying to touch on too many things here, Zach. Do you want to help me transition here? Anything else you want to add on arrays and lists?
Yeah, so just for arrays and lists, it can get blurred depending on which language you use. I'll speak to Swift really quick. Um, Swift arrays are pretty much the same as arrays and lists combined. They're dynamic, so you can subtract values, or I mean, remove values, and you can add or append values to the array. But in some languages, when you create an array, it's set at a certain size and it can't grow any bigger. To get it bigger or anything, you'd have to create an entirely new array. And that's kind of what happens in the background. And some languages handle that for you. Java has array lists that you could use. That would be pretty much what we're talking about. They have just a basic list. I don't know. But yeah, a list is ideally a dynamically sized an array, and an array is just a lit like I'm not going to say it's a group of values and it has a constant size. But
And
that obviously depends on the language. So
Elon Tusk hits on a good point. There's lots of trade-offs, and that's kind of what we're trying to hit on here. Is that not only should you know how the data types store things, you should know how the data types allow you to add things, you should know how the data type allows you to remove things, and how the data type allows you to search for things, or whatever operations you're going to be doing with the data structure that you have. You should know the cost that they have, so you should know why I would use one versus the other. For example, if I'm creating an employee directory, right, I don't want to use an array because I don't know how many I'm going to have, depending on your language, obviously. I guess not obviously. Depending on your language, you wouldn't want to use an array because when you create it, it has a fixed length. Whereas as employees come and go, you're going to be wanting to add and remove from that employee list, right? So in the long term, it may be quicker to use a list than to use an array. And Jonathan does have an important clarification that I'd like to touch on. When I was talking about when the list is sorted, when you want to insert something, since it's pre-sorted, it's a lot quicker because you'd know you'd have a quicker algorithm to figure out where to insert this for because you'd know it would be um, greater than 3, for example, because it's sorted, right? Whereas if it's random numbers, you don't know where the 4 would go, you would just add it to the end. And then, if you're searching, that would take longer if it's not sorted. Zach Vaneeth has a Swift question for you.
yep. So in Swift, a list is let array, and type that out quick. So let's see. So let some array and give it a type of, let's say, a strings. That's technically a list. Well, actually, sorry. This this is a little bit different, and this gets into the specifics of Swift. And now I'm being a stickler because this is actually, I would say more. Oops, those are not strings. Um, there we go. Oh, when you
We can't
press
see your typing
escape,
yet.
when you press escape, it deletes the whole thing. I'm trying to edit, but pretty much, let is a constant, so I need to give this array a value, and at that point, I can't modify the value anymore. So I would call that more an array. But if this was var, here we go. I'm still learning this thing right here that we're using.
This
So
might
if
be a
this
good
was,
explanation and a note to write down for the Swift tutorials
yeah, and
before we
also
get too off
last,
topic.
yeah, this was the last point, is once
Yeah,
you
sorry.
switch it to var, the array can be mutated. So then it's more of a list. So I'd say a variable array is like a list, and a let array is more of a constant array. If it's a very thin line.
Raid asks, neither arrays nor lists can store different data types, right? It depends on your language. For most languages, when you create an array, you give it the type of things that it's going to create. Um, I think JavaScript and Python can hold lists of different typed objects. I could be wrong, but off the top of my
Y-
head, that
y-
sounds right.
yeah, that's right. And then Swift can too. It just kind of depends on the type. We have an any type that kind of encompasses everything, but then you don't know about anything of any of the objects. You just know it's, hey, that's something. You just know it's any, at least from a typed perspective. But from JavaScript and Ruby or Python, those are still like anything. Those are like still objects that could be dynamic or different.
Marat says, "Can't we hold many types by declaring a dynamic list in C sharp?" I have not a clue, but that sounds like something I would have fun looking up. I'll write it down and look it up. I have a C sharp tutorial series that I go over. I don't want to get too deep into a specific language today, but if you want to come to the next C sharp tutorial stream, it's on Wednesdays at 7 p.m. Vineeth asks again, what's the time complexity of inserting an element into an array? And since we know the indices of the arrays, it's constant time complexity. Um, and since Vineeth brings up the topic of time complexity, you'll hear a lot about time complexity, big O notation, and so on. I just want to add a quick clarification how that works. Um, Really, what it's trying to say is how long does it take to do an operation? And it could either be the notation that they use. I'm just gonna keep doing everything in this box that I have here. It would be, oh, I'm not on my pencil. It would be O, like, and then parentheses to represent that it's a function. Actually, I should just type this in text. It would be O and then some value to represent how long it would take, right? So you could have O of n, which would be linear time. You could have O of, I guess the more simple version of that would be O of 1, which would be some sort of constant time, right? So you'd know that if it's constant time, whatever operation you're doing is going to take maybe not the same amount of time, but a specific number or a specific amount of time every time. Whereas a linear time complexity, if let's take what would be a good example of a linear time? Um, Man, what kind of a linear search, right? If I just have an array of objects and they're not in any sorted order, and I just want to keep saying, is this element the one that I'm looking for? Like, I don't know, let's say we're looking for an integer. Is this element equal to 1? No. Is this element equal to 1? And you keep going. If the list gets longer, then we're going to scale with the length of that list, right? So that would be linear time complexity. And then what would be a little bit quicker than linear time complexity would be, um, come on, log of n. So it would be an inverse exponential, right? So instead of the longer the list gets, it doesn't grow by the length doesn't grow by 1 every time you add an element to the list. It grows by the log of that. So every power of 10, it would increase by 1, basically. And you can find algorithms that would do that, like binary searching, right? If I have a list of 100 elements and it's sorted, and let's say the numbers are from 1 to 100, and we're looking for the number 25, well, if we cut the list in half and we say, or if we look at the middle element and we say, is 50 greater than 25? Yes, then let's look at the bottom part of the list. And then you cut it in half again, and you'd say, is 25 greater than 25? No, it's the right number. This is where we're at. But you see how it would cut the list in half every time. So that would be log of n, or log 2 of n if you're familiar with logarithmic basis. And then after that, like if you typically you'll see linear algorithms be used with for loops, and then after that, I don't know how I do exponential notation in this, but I'm just going to represent the caret as a square or as a power. So this would be n squared. You can have n squared algorithms. So let's say you have a 2D array, right? And let's just imagine you're looking at a grid and you want to find the middle element. Well, if you do a for loop going horizontally, and then you have a for loop going vertically, depending on how your list scales horizontally and vertically, it's going to be a squared length of time to search through it. And then the algorithms can get more and more intensive and costly of time complexity. But that's the very very basics of that. Anything you want to add to that, Zach?
Other than I added
A graph?
a graph from my Mac
Uh,
of it.
so
No,
the
that's really good. The other thing I would touch on really quick that we don't have to actually touch on that much is there's time complexity, but then there's also space complexity.
Which would be how much memory your program uses.
Yeah,
So
which is just kind of in the back of the head, like just, anytime you create a variable, that's memory that you're allocating. So just be cognizant of if you're programming, how much memory are you using. That's kind of understanding your space complexity. But
and
we can always get into that in another
and just to, I'm gonna go a little off topic here, but
Go for
just
it.
to emphasize the importance of knowing this, we could go more into detail of it. There's lots of tutorials out there for it. Just look into time complexity. Um, these things are going to be really important because not only is it going to make your programs more efficient, but if you go to an interview, let's say you're going to work at Amazon or even a local company, a very common set of questions revolves around time complexity. They say, "Hey, go make this program that checks if you uh, if a string is a what's the word I'm looking for? If it's the same front ways as back ways.
Palindrome. Yeah.
Palindrome. Thank you. Like if you're checking if a string is a palindrome and you do an algorithm that has a time complexity of n squared, they're going to say, okay, that's a really inefficient algorithm. How could you make it efficiency of n or log of n, right? And then you say, okay, I got my time complexity down to n, but now I'm using way more memory because my solution happens to store a bunch of extra variables, right? So when you're programming these things, you want to think about which data structure is the most efficient for me to do what I'm trying to do in both the amount of time it's going to take to compute and the amount of memory that it's going to use because it's going to be a recurring concept that shows up in your career. Um, so yeah, those are the very basic data structures that we wanted to go over. Zach, were there any other ones that you wanted to hit on? I know you talked about tuple. We could talk about that as well. I feel like that's kind of language dependent, though.
Yeah, but I'd just like to touch on it because quite a bit of languages have it.
Yeah, go for it.
And just because quite a bit of languages have it, there's, I'm going to paraphrase this quote of whatever language you use kind of is the basis of what you think or how you think of ways to solve a problem. I'll have to look for the actual link on the quote because it's a good quote.
And it wasn't
But
necessarily talking about programming languages, was it? It was talking about like
mhm.
if you know English, you think about uh, you critically think in a certain way, whereas if you know like Russian or French, you may think about it in a different way.
Exactly. And it was about, yeah, spoken language. It wasn't about coding, but it definitely translates to programming and coding with different languages. But for tuple, the idea is I want to group some variables. I want to group some values together. And it may be two, or maybe three, four, or five, whatever. But it's like a group of values. And normally, in some languages, of course, it looks uh, like that. Uh, Can you see that? It's on the left.
Yeah.
Um, yeah. So it's this is a tuple of two ints, 0 and 5. But it's an easy way to group values. So this could be a quick way to have X and Y. Or a lot of languages have to create a class or a struct called the point class or a point struct, whatever. But in some, functional languages, you can just go with this and know that the first value is X and the second one's Y. So there's a difference of that in tuples and how languages handle it. Maybe, you wanted a tuple that was the X and Y and then whatever the name of the game or the player was. Sadly, this one's a rock, but that's a tuple with three values. The first two being ints, and the last one being a string. So if you were to use this in a language that didn't have a tuple, you'd have to make a struct or a class that just stores this. And this is just an easy way to hold these values. Um,
That's a really good point.
the Yeah, and I don't want to get too much into language specifics, but yeah, it's always on a later point because I can touch a little bit more on this in Swift or
Yep,
another language.
and C Sharp has these as well. So if you guys are interested, look at either Zachariah's C Sharp and Swift tutorial series in the. We have playlists for them on the YouTube channel. We're on the first of all these series, and we're starting them all simultaneously. So, Elon Tusk did ask a good question here. Is there a tool that shows time/space complexity of an algorithm, since it can be hard to Intuit at a glance? I actually don't know one off the top of my head. A good
Okay.
way to test this might be to go to an online program solving website like codewars.com. And when you run the program, you'd see how long the program took. And as you change things, you'll see how long it takes. Because basically, what they're going to do is they're going to run your program with a set of tests, and as things change, you'll see how long your program takes. You can also set up a program that has a timer on it to see how long things takes. Off the top of my head, I don't have a good tool, Zach. Do you?
Well, no, it's tough because there's so many different languages that you can write it in, right?
If you have questions on what the complexity of an algorithm would be, feel free to reach out to Zachariah in the Discord, and we'd be happy to help you take a look at it. Otherwise, if anybody
I,
has a good idea of a tool, feel free to post it in the stream chat.
I don't have a tool, but I have kind of a tip, or at least a general kind of methodology that I go about of going to look at time complexity. And it's first to look at any loops. Once you see a loop, then you know that you actually have some time complexity, right, Sabian? Like if you don't have any loops, I don't think there's really a case in time complexity unless you have an asynchronous task or a synchronous task that's blocking, or
And
maybe asynchronous too.
and definitely look for loops inside of loop. Like if you do a for loop and then a for loop inside of that, that's definitely going to be really expensive. I mean, it may not be because you don't
Hmm.
have very many elements, but as it scales, it will.
Yeah. So with nested, like Fabrice said in streaming discussion in Discord, that's where you're gonna have that. Oh, you don't have the examples anymore. I was gonna show it,
Oops, sorry.
but yeah, that's where you can tell. Like if you have one for loop, then it'll just be n, and then two will just go on and on. So that's at least a way to kind of get an idea of it, or that's at least what you're trying to look for, is some loops or some cause for.
And we don't like I would love to pull up C sharp and just like show you guys an example,
Hmm.
but a lot of you guys may not know C sharp. So those questions may be good to ask in our language specific. I hate to keep like self shamelessly plugging those things, but we're really trying to
Yeah.
make these things language agnostic. Um,
Yeah, no, but that's a good point of like when we're doing those ones specific for the language, we should always be thinking of, hey, what's the time complexity for this? Can we make it a little bit better and that stuff? So yeah, that's something that Sabian and I will have to work on while we do code along on the streams. We'll definitely bring up the time complexity and take a step back and say, hey, what do we think this is and why?
that
But I think that's it. I
yeah,
don't want to touch on arrays and lists for too long. That was
yep.
about tuples. So
Vineeth, I would be careful with that statement. Um, I wouldn't say no tool can help you in calculating that. It wouldn't be terribly difficult to make a tool to kind of predict how your algorithm scales based on tests passing in data. I can't name any tools off the top of my head, but I can't help but think it's possible. So, are there any other questions on data structures before we move on? I know this was a really basic talk for some of you, um, but we really wanted to. This discussion was more for those that are brand new to programming, and we can talk about way more complex data structures as time goes on, like graphs, trees, linked list, queues, stacks, those type of things. Um, and those will definitely be important, and we'd love to go on to those. But we're trying to keep this stream kind of concise. So if you guys don't have any further questions, we'll move on to talking about Git.
ooh, okay. Are we gonna talk about structs versus classes?
That's a good point.
Because I was getting that a lot in mine,
Yeah,
and I don't know if we can kind of just generalize across
yeah.
languages what struct versus classes mean. Um, looks like we have some conversation in chat. Responding. But,
So
uh,
there's two. I'm gonna type them out so that they see the wording. A
yeah, yeah,
struct
that would
and
be the
a
best.
class. And we're gonna have to somewhat generalize because these things don't exist in all languages. For example, a class doesn't exist in the programming language C. In general, a struct is used to hold data, and it can have functions inside of it, whereas a class is used to hold data and functionality. Right. So I like to give examples so that um, these can kind of sink into your memory. So, for example, I can have a struct like Zach talked about earlier to hold point data. I can have a struct that has a float representing int, or a float representing x and a float representing y. I could have a struct representing data for a customer, and it could have his name, his address, his email. Whereas a class is more suitable to have functionality built in. A struct in a lot of languages
Mm,
still can have functionality. The major difference that you're going to find is that a struct is meant to hold values, whereas when you hold reference to a class, you're going to pass that reference, right? So if I say in part of my program, here, use this struct, if it modifies that struct, it's modifying a copy of it, right? So if I pass a struct into a function and that function uses the struct, it won't have the reference to that actual spot in memory where that struct is stored. It will create a copy of it and edit that. Whereas a class, if I pass it in somewhere, it will actually look at that exact same spot in memory, and if you edit a class's attribute, it will actually edit the exact spot in memory that class is referencing. Oh, Vineeth, yeah, I forgot about dictionaries. That's a really good
yeah,
point.
I was gonna
Thank you for the
say
reminder.
go back on that.
Okay, so I hope that was clear on structs and classes. That was a very, very brief overview.
Well, yeah, we'll come back to that after dictionaries and hash maps to touch a little bit more on or answer any questions about structs and classes.
Okay, so dictionaries. These are so wildly useful because of how insanely fast they are. Dictionaries and hash maps are very, very similar. Oop, excuse me, pardon my burp. So a dictionary, what is it? It is some data structure that is a list of keys and values. So you have a key and a value. So what types of things could these be? Maybe my key would be um, somebody's name, like Joe, and the value would be his address, 123 Meadow Lane. And I could hold a dictionary of these things, right? Dictionary, like the dictionary is kind of an intuitive concept, right? You have the name of a word and its definition. Well, it's a dictionary is just a dictionary in programming is a more generalized version of like an English dictionary, for example. It it has a key and a value, and a key is used to look up a value, right? And the reason we like to use dictionaries and hash maps is that they have instant lookup time. If I have the name of a key, it knows exactly where that is in memory, and it can instantly look it up. I mean, I don't want to say instant, but it's constant time, as we talked about earlier. Yeah, Jonathan, that is an important clarification. Hash maps are more of a Java implementation. Another name of this would be a hash set.
And
And
just a map too. It's also
or
there's
yeah, Swift has just maps, right?
no, it's dictionary for Swift, but I think in some languages map just
Got it.
but like hash map, yeah, shortened.
So a lot of these things, if you add up all the names, it should kind of make sense. If you map something, you transform it from something to something else, right? So I could, in some languages, you can map from, I don't know, an integer to a string, and you say if the integer is 1, then let's output the string 1. If the integer is 2, let's, I don't know, we're squaring it, you output the string 4, and so on and so on. The reason we use these things, I want to reiterate, is the constant lookup time and the capability to store complex data. I mean, arrays and lists can store complex data as well, but having a key and a value makes it very easy to look these things up and store that complex data. Um, yeah, another way would be to call it a hash table. For those of you that are unaware of the term hash, a hash is basically a way of transforming something into a unique characterization of itself. So if I give a hash function, right, because it's a function that turns something into something else. If I give a hash function the number 1, maybe it outputs a random set of numbers and characters. And if I have the number 2, it wouldn't transform linearly, it would be another set of random characters, right? And so the beauty of that is each of these things has a unique reference, right? You know that for every input that you give it, it's going to have some unique output. That's what a hash is. And this could be done in multiple different ways. Maybe it takes a timestamp, right? It says we're at this current number of milliseconds since your program has started, and we'll use that as some sort of transformation to turn whatever your input is to something unique. But if I were to put in the number 1 again, I would get the same output regardless of what's going on. Dictionaries are commonly seen in a data format called JSON. JSON stands for JavaScript Object Notation. And I know it says JavaScript, and that may not you may not think that applies to you, but it's a very common format of storing data because a dictionary makes it very clear what types of things are being stored. If I just go type in, I don't know, JSON data, and I don't know, I'll pull up an image here. It would look like this. You would have some key, so the platform, and then you'd have some value, which would be Android. And it's a list of these keys and values, right? So my object that I would hold, my object has a platform, a favorite food, and a language. And another object that I would hold would have, three keys and three values, and so on and so on, right? So a platform couldn't just be iOS. A platform could hold, you know, the name of the platform, its version, and like, it could nest inside, right, and have substructures within inside of it. Any further clarification that I should add to that, guys?
Depending on your language, of course, maps or dictionaries are really cool because you can pretty much make the key anything that can be hashable can be a key. So like Sabian said, if I have this sum class and it just can be hashable or give me a hash, then it could be a key for some value. Looks like we have some questions of, we have two different sources. One in Discord, value versus reference types, kind of going back to structs and classes. And then we have one in YouTube, Max, saying also worth noting JavaScript's casting to strings.
Yeah. So the reason JSON is JSON, the reason it's called JavaScript object notation is because when you turn anything into a string in JavaScript, when you turn any object into a string, it automatically turns it into JSON, a human readable format of that object, which just so happens to be a dictionary. Good note, Max. I would if we fun wording. If we rehash on structs and classes, I would highly recommend looking up value versus reference types. That will give you a good starting point to understand why struct is a value type. It passes by value. It passes a copy of a value, whereas a class passes the actual reference to that spot in memory for it to edit. Oh, ooh, Vineeth, I love that
Do you?
idea.
Oh, okay.
Sorry, go ahead.
Oh, I was just gonna see if we wanted to draw out like the consequences of a reference versus value. Like if you pass me a reference and I modify it, what happens versus if you pass me a value and I modify it, what happens?
Sure.
Um, because that's like the real concept, right? Like I can just summarize or we can draw it. But pretty much what happens with the value versus reference type is values. Um, they don't point into the spot in reference or in the spot in the address of where it's stored in code. Reference types. Oh, now he's asking for stacking heaps. Oh, he's just going digging into it. This is supposed to be like the first one, Fabrice.
I've
So yeah, reference, pretty much you have a reference or a class and you pass it to this function. If the function modifies it, both of those, when you have it and when it's in the function, are pointing to the same point or the same address in memory. So it will modify that value. If you do the same thing with the struct, if I have this struct and I have this object and I pass it into a function and that modifies it, well, that won't actually change my value, because whenever a struct is passed, it's a value type and it will just change the value of what you have versus the actual reference. And that's kind of weird because it depends on the language, how they handle it. Um, oh, he's saying they're not questions. He's just saying stuff. I love it.
all right. We can move
um,
on.
yeah,
Okay.
that's a little later topic.
Okay, I'm going to answer some of these questions and not others because some of them are more complex and they'll take, almost a class of their own. For example, binary search trees.
Yeah,
Vineeth brings up
is
a
yeah.
good question about enums. So an enum is a fairly common data type in most languages. Enum stands for enumerated type. Enumerated means you enumerate or list all of the things that this type holds. So in most languages, you can say enum and then the name of the enum. You could say days. And then what days are there? there's Monday, Tuesday, Wednesday, and so on, right? You can enumerate it because you know all of the options, right? And what's beautiful about that is, say we have some variable called current day. You could do an if statement and say if the day is Monday, if the day is Tuesday, and so on, right? And what's nice about that is instead of will you let me edit this text? Come on. Okay. Instead of saying if day is equal to days dot Monday, the naive approach would be to say if day is equal to and then just the string Monday. And what's scary about that is what happens if you have a typo on here, right? Having an enum prevents the possibility for there to be typos because that type is already enumerated. And not only that, but you know what all of the possible states that your program can have, right? You know if the day is an enum value, it can only hold these 7 days, or there's tons of different options that you can use for enums. Um, for example, in video game development, I might have an enum to say player actions, and I could have running, walking, idle, shooting, reloading, and so on. And I could just check the current state of my player and do something, according to whatever the current state is, right? Enums are really useful for managing state because states have finite, finite meaning like concrete states that they can have, right? Catching up on chat here. I don't know. I feel like enum would be considered. I guess this question was, is enum a data structure? Uh, I'd say yes. In lots of languages, like the values themselves are mapped to some integer value. So, for example, the first value would be 1, the second value would be 2, and the third value would be 3, and so on. Or you can declare whatever the types are themselves. So it's almost like a dictionary saying this is the key, and whatever the integer value is its value. Is its value. Um, so yeah, I'd say they're a data type. They don't really have complexity per se. It's constant, right? Because when you do like days.monday to look up the actual day in the enum, it just knows what day it is, so it's a constant lookup time. Anything to add to enum, Zach?
No, nothing other than trying to specify them other than a data type, like kind of a variable type. I'm trying to look up on the internet, but yeah, I guess kinda.
Max, I think that's a good.
Um,
I think that's a good description. He said an enum would be an application of dictionaries. Yes, that would be correct.
yeah, it also depends on what language, because
It may not map to an
like
integer.
coming from Swift, I could do weird things with my enum,
You could put
and even
functions in
have a
enums, for example.
class. Yeah, I could put functions or a class inside of my enum. So it depends, but generally it's used to give a static type, or something to type in and have solid. So if you have strings, you might want to replace them with enums. So if you're trying to look at the days and it's equal to Mondays as a string, yeah, you're definitely going to want to use an enum, like Sabian said. That's a great example.
Okay. I think we're gonna save your binary search tree for another stream. Trees and graphs are a very complex topic. They deserve almost a stream of their own for each one.
Hmm.
Um, I feel like we've gone on long enough that this is almost its own video. We're at an hour right now.
Yeah,
Do
so
we
we're
want?
gonna switch it to the Git one,
Yeah,
right?
we're gonna. Do we want to end the stream and move to another stream specifically on Git, so that way it's easier for them to find it, or we just want to put the timestamps in the description? What are you thinking here?
I was thinking let's just end it, make it easier to get them into separate videos.
Okay,
We
I'm gonna.
wanted to break them down, so.
Yeah, I'm gonna leave the stream open while we're chit chatting here, while I'm setting up the next stream. I will put the link to the next stream in the stream chat. So for those of you that aren't interested in Git, feel free to hop out and do whatever you're doing. But for those that are interested, give us just a second. I'll keep my eye on the stream chat if you guys have any questions. Oh, didn't mean to do that. Ooh, I'm so happy we have a whiteboard for Git. This is gonna be beautiful.
Will we cover git merge and git rebase? Most likely yes, but that will be a little bit later after we talk about branching, commits, push, pull, fetch, stash, and yeah, we will talk about merging and rebasing. What's the difference? When would you want to do one versus the other? That's a great topic.
All right, the new stream is created. Let me grab the link for everybody that's still interested. Do, do, do. No, not going to give me the link. I see how it is. Me not knowing how to use YouTube. We may not go into detail on how to handle git, merge, and rebase, but we'll definitely at the very least, cover the basics.
Yeah.
It's basically as
And,
time permits. We kind of want to just cover whatever you guys are interested in.
and we may also end the whiteboard too. So
I'm going to keep the whiteboard open for the beginning of the git stream because the showing how branches work is useful.
yeah, you didn't see what someone wrote though. So okay,
Oh.
we may end the whiteboard in the next get if something still happens.
I'll make a new link. Okay, I'm going to end the stream. I put the link in the YouTube chat. We will see you in the next stream in just a minute.